All right, guys, example 5. Are you excited? Honestly, guys, at the end of this section, if you guys are not good at graphing, I don't even know what to say, right? We're graphing so much. F of x equals negative square root of x minus 5 plus 4. So, y'all, the name is square root. Okay. A is going to be -1, H is going to be 5, and K is going to be 4. Let's try to find the y-intercept immediately. Yep, even without doing any of the tables of the points, okay? Again, plug in 0 for x, so that's negative square root of 0 minus 5 is negative 5 plus 4. Whoa, what's happening under the square root? It's a negative number, so guess what? It's not possible to have a y-intercept, so NA. Now, and even without graphing it out, if we have an h value, students, okay, of 5, meaning that we have shifted to the right 5 units, so 2, 4, 5, up 4. This is one of the dots, right? That's your initial dot. So if we shifted up 5, if we move to the right 5, we are not going to hit the y-axis or touch the y-axis, okay? So quickly, if you can get the parent function, y equals square root of x. Remember, square root, we want nice square numbers. So 0, 1, 4, 9, 16. Those are really perfect square numbers. 0, 1, 2, 3, 4. Those are the outputs. We can quickly use transformation to make a table. X plus 5, -1 times y plus 4. 0 plus 5 is 5, 6, 9, 9 plus 5 is 14, 16 plus 5, 21. 0 times -1 is 0, plus 4 is 4. 1 times -1 is -1, plus 4 is 3. 2 times -1 is -2, plus 4 is 2. 3 times -1 is -3, plus 4 is now 1. 4 times -1 is going to be -4, plus 4 is 0. So it looks like we have an x-intercept. All right, let's plot them. So our first point is already plotted at 5, 4. This is your HK, okay? 6 is now 3. 9 is 2. I'm going to graph out this last, I'm not going to make 21 tick marks, okay? But I will maybe eyeball 14 more here. So that's going to be 1, just like that. So it is decreasing, just like that. Well, the domain of this particular square root function is the smallest x value we have is 5, and it goes to the right indefinitely. The range is the highest value we have is 4, so we have -infinity to 4 inclusive. And that's the square root, y'all. Let's go to 6. Now, cube root, we can have negative and positive numbers for inputs and outputs, okay? So AH and K, same 3 AH and K values. AH is 5, K is 4, okay? Parent function, y equals cube root of x and cube root, all right? We can also go in and find y-intercept manually to see if we have any. So f of 0, negatives in the front, 0 minus 5 is cube root of -5 still, and then add the 4 outside. Now, because you do have cube root of a -5, think of it like this, it's -1 times +5. So cube root of -1 is -1. Well, you don't have a negative in the front. So a negative times a negative is now going to be a positive in the front. So under the cube root, we have just a +5. So student, y-intercept, which is simply cube root of 5 plus 4. Yes, you can leave right now for that exact answer. So we can even write 4 plus cube root of 5. Wouldn't that be okay too? But I need to write 0, 4 plus cube root of 5. All right. Now the domain and range for cube root function is going to be all real numbers. Okay, cube root and cubic functions. The domain and range, all real numbers. Fill it in, even without graphing. All right, so parent function, quickly get -2, not -2, I'm sorry, -8, -1, 0, 1, and 8. Output -2, -1, 0, 1, and 2. Now over here, I'm going to use A, H, and K and make my transform table. X plus 5. Okay, this transform table, let's try to make it here. So x plus 5, -1 times y plus 4. So take all of your x values here. -8 plus 5, -3. -1 plus 5 is 4. 0 plus 5 is 5. 1 plus 5 is 6. 8 plus 5 is 13. Take all the y values. -2 times -1 is 2. 2 plus 4 is 6. -1 times -1 is 1. 1 plus 4 is 5. 0 times -1 is 0. Plus 4 is 4. 1 times -1 is -1. Plus 4 is 3. And then the last one is going to be 2. Okay, let's plot the dots. Ready? -3. Go up 6, 2, 4, 6. +4, up 5. 5, 4. This is your HK form, HK point. 6 and 3 and 13 up 2. Okay, so goes like that. Bam. All right. As you can see, domain and range are both all real numbers.